Hello everyone, I'm recording this for the HEC HMS number 3 lecture. Okay, let's begin. So if you download the lecture PDF file from iClass, this is the PDF file you'll have. Okay, so the study area is again Taehwa River watershed. This is the same watershed that you got for your homework. And I know it looks like this, but when you flip it or rotate it, it looks like this. So this is what you had for your homework, right? It's the same watershed. And then we also have information for the subbasin areas and time of concentration, storage coefficient, SCS curve number, and impervious area. And for the fire beaches, we have the Muskingum K values and Muskingum X values. And we also have the precipitation data from 2000 January 1st to 2000 January 2nd. And then we have these equations. So, if we didn't have the values for the Muskingum or the other, let me go back. So if we didn't have the values as a table like this, then you have to use these type of equations to find the TC and the K values. And if you look here, we have like list of TC, T sub C equations, like Kirpich, Riza, Craven 1, Craven 2, and so on. And for storage coefficient K, we have Sabo, Muskingum, and so on. So these are just equations that you might need when you're using HEC HMS when you don't know the values of TC and K, okay? And then, so let's talk about a shapefile. So today is a little bit different from HEC HMS Part 2 because we'll be using a shapefile, which we normally use in GIS. So a shapefile, what is it? So it's a widely used geospatial vector data format for storing the location, shape, and attributes of geographic features. It was developed by ESRI, Environmental Systems Research Institute, and is compatible with most GIS software, like ArcGIS, QGIS, and HEC HMS. So basic concept is that a shapefile presents geographic features using one of three geometry types. So first, we have a point, that's for discrete locations. We have a polyline next. So a polyline is for linear features like rivers and roads. And for polygon is for the area features, and they're like basins and lakes and so on. And each feature has both spatial data. So spatial data means coordinates that define the feature's shape on the map. And it also has attribute data, so information stored in a table, like name, area, length, and code. So next we have the main components of a shapefile. So although it is called a file, a shapefile actually consists of multiple files that work together. So we have file extension .shp. So you're going to have like a list of files in the folder that I shared with you guys on iClass, and once you open it, you're going to see all these different file extensions. Okay, so if it ends with .shp, then it stores the geometry, SHX, shape index, linking geometry attributes, dbf, a database file that stores attribute table data like name, area, code, and prj. This one defines the coordinate system and projection. And then we have QPJ, GDR, and etc. others, optional files used by specific GIS programs. So all of these files together make one functioning shapefile. So if we look at our shapefile for this lecture, Taehwa River shapefile, we have the first WNATL.SHP. So that's for a river classification level, it's a national river, so NATL. And then river example is the Taehwa River, and then this is the main national level river managed by the national government, and it's the final outlet of the watershed. And then we have the W_FRST.SHP. So this is a local level river called Dongcheon. So it's a major local tributary that joins the Taehwa River. And then we have the SCND.SHP. So that's first, and this is second. Another local level, but this is like smaller secondary tributaries feeding into Dongcheon and Taehwa. Okay, so used in HEC HMS in hydrologic modeling, subbasin shapefiles define watershed boundaries and areas, and river shapefiles define stream networks for flow routing. together they form the special framework of the HEC HMS basic model. So when we import the shapefiles to HEC HMS and open them up, you're going to be able to see them in a table format like this. Okay, so 태화.shp, it says the attribute table for 태화.shp shapefile, which defines the properties of each subbasin polygon in the 태화 river watershed. So, you can look at all this details yourself. So, for example, the first column FID is feature ID, shape, it says polygon, it means geometry type, and BBSNCD is basin code, MBSNCD is main basin code. So all these, names in the column are just short version, abbreviated version of what it means. And you can take a look at all this explanation on your own, okay? Because I'm going to share this file with you on iClass. And next we have the WNATL.SHP. So this was the national river, and you can also look at all the explanation and details on here if you want. And then this is the W_first, so you can also look at the explanations for this yourself. And same thing for this. So this is what is important. So once we import the GIS file, we're going to have all these subbasins, the green subbasins, and then it's also going to automatically, when we import GIS to HEC HMS, it's going to come with the subbasin icon, this icon, like all these subbasin icons, and you see the numbers 220102, 220101. So all these numbers and the subbasin icons and the drawings of the subbasin do come to the HEC HMS automatically when you import GIS to HEC HMS. Okay, so the only thing we're gonna have to do is create these links and reaches and these junctions, and that's all you're gonna have to do when you have GIS file. So having a GIS file make things easier. Okay, so let's have that let's have that open like that, and then let's look at the files. So once you download the file and then extract it from the zip file, the shape file, it's going to look like this. So like I've explained already, there's like a DBF, GDR, PRJ, QPJ, SHP, SHX, all these different files. So this is how it looks like when you open it. So let's start our HEC HMS. Okay, so let me bring this up. So just like any other time we use HEC HMS, go to create a new project, click on that. Let's name this HEC HMS 3, and then let's change the unit system to metric, and I'll just save this to desktop, or actually just documents. So click create, and we have a new project, and let's go to components, basin model manager, new, create, close the manager, and then go to where it says basin models folder, click on that, click on basin 1. So we have this window open up here, and then let's go to GIS. Okay, so it's next to components. Okay, and then if you go down here, it says GIS, and then if you go down, import georeferenced elements, click on that, and then element type, so you have to choose element type. Let's just stay with subbasins, click next, and then you have to find the GIS file you want to bring in. So click on this icon that lets you browse your computer. Okay, so this icon, and then let's go to desktop, because that's where I have my shapefile. So if you go to your shapefile, you're going to see these 4 shapes. So let's start with the Tewa shapefile. So select, click next, and then here we're going to actually go with SBS NCD for the Tailhua shapefile. Okay, SBS NCD. That was SBS NCD is sub-basin code small unit. Okay, so let's go with that. So finish. We can just skip on this. And here we go. So we have the sub-basins. So I know it looks a little bit different, but it's basically this, but you know, rotated to the left like this. Okay, so it's the same watershed, just rotated the other angle, so it looks a little different. So yeah, so basically we're trying to do this onto HEC HMS. So let me just adjust the size here so I can look at my PDF file while I'm doing it. Yeah, so we're here. So you know, we have the subbasins already, subbasin icons already. So let's bring in more stuff. So go to GIS again. Again, import georeference elements. Okay, so it's not georeference existing, it's this one. Import georeference elements. Next, again, browse. Go to where you have your shapefile. Let's go with the NATL one this time. Select. Next, and here we're going to stick with index page 1. Finish. And now you see that we have the river, right? The national river. So this, you know, river's sub-basin feature has been added here, you know, because we imported the shapefile, okay, for that. And then yeah, we can go to GIS again, import georeference elements. Next, open the folder, go to where you have your shapefile. Let's import FRST. Select. Next, index page. That's good. Finish. And you see we have yeah, we should have another river that's been imported. I believe it's this line. Okay, so this line has been added now. Wait, let me see. Oh, whoops. Oh wait. Okay, so when you import another shapefile for the rivers, the names are automatically set as 213. So before you import them, you have to change the names of the river you already have. So let's change. So if you right click on this, you can rename this. So let's rename this as Tailhua. And then go to GIS, import georeference elements. Next, go to where you have your shapefile, open it. What was it? Oh yeah, so it was first. Yeah, so FRST. Select. Next. Finish. Yeah, so now we have this new one that's called 213. But let's just change this to, so if you remember FRST, the name was Dongcheon. So okay, just right click on 213, rename, and let's type in Dongcheon like that. So DONGCHEON. And for Tailhua, it was TAEHWA. And then let's go to GIS again, import georeference elements. Next, open the folder, go to desktop, SHP file, open. Let's open WSCND, select, next. That's good, finish. And yeah, so now we have bunch of more rivers, the smaller rivers. So if you have paid attention to here, You see that like the SCND shapefile had all these different river files that are like a lot smaller rivers all over the watershed area. So yeah, that's what we have. And then